Every age has its own image of the world, and every image reflects the vision of its time and of its maker. This is a 19th century image of a one-celled organism, a radiolarian. Its skeleton is a series of concentric shells connected in a single crystal web. It was found at the bottom of the sea. That image was made by biologist and artist Ernst Haeckl, for whom the elegance and complexity of these tiny creatures embodied the unity of science and art. There are 5,000 known species of radiolaria, fossil and living. Haeckl alone discovered and described almost 4,000. He named and classified them, drew and painted them, and in their astonishing variety, he sought the key to the creative power of nature. For Ernst Haeckl, the radiolaria would become a lifelong obsession, a doorway to the mysteries of life itself. Through them, he would become a major figure in the history of evolutionary theory. One of the most widely read authors of the 19th century, his books translated into over 20 languages. The shaper of images of nature and the order of things, which would cast a wide and complex shadow over his era and our own. Late in life, on the eve of the 20th century, he would produce an extraordinary vision of pattern and structure in the natural world, which he called Art Forms in Nature. Haeckl would come to regard the chief task of the scientist as identical to that of the artist, to depict the world around him with both the precision of the meticulous researcher and the passionate intensity of the mystic. But to arrive at this vision, he had to integrate two conflicting worlds: an outer world of rigor and system to be discovered through science, and an inner world of strange and dark-lit forms glimpsed through poetry and art. They seemed irreconcilable. Since the time of Aristotle, Western man had viewed nature as ordered, external, and objective. The creatures that crowded medieval bestiaries were fixed and permanent forms, put here by God on the sixth day of creation. By the 18th century, the philosophers of the Enlightenment had come to see the natural world as a vast and orderly museum, established perhaps by God, but illuminated by the clear light of science. A sophisticated man like Thomas Jefferson could say even in 1770 that not a single species had been lost since the creation. But by the early 19th century, Romantic poets, artists, and nature philosophers had turned this vision inside out. The outer world had become a window to an inner landscape. it was a world of constant change and metamorphosis, cataclysm and conflict, buried light and hidden meanings. The objective tradition of the Enlightenment would have a huge influence on the 19th century life of the mind. But the inward search of the Romantics would exert an equal and opposite pull. Ernst Haeckl, as a young man, would be caught between these two seemingly incompatible visions of the world. He was born in 1834 to a family of lawyers and judges living in Prussia and Saxony. His parents were liberal Protestant intellectuals who steeped him from childhood on in the pantheism of Goethe and the radical theology of Friedrich Schleiermacher. Raised as a Christian and trained as a scientist, Haeckl would find himself torn from the very beginning between a world of spirit and a world of matter.
There is one problem that occupies me a great deal, and the more I try to discover light and truth in it all, the more dark and confused it appears to me. It is the relation of our modern science, of which I consider myself the most ardent apostle, to Christianity on the one hand, and materialism on the other. The deeper research penetrates and the further natural phenomena are reduced to mathematical formulae, the greater grows the temptation to seek the last cause of all things in mechanical, blind, unconscious, natural law. And yet how empty, how superficial, how insipid is this conception driven to its culmination point, and how unsatisfied and comfortless it leaves the soul that is striving after truth and enlightenment.
Haeckl's model and guide in his struggle was the poet and naturalist Wolfgang von Goethe, who had towered over the birth of the 19th century. Goethe had rejected the God of the churches and had begun to speak of God in nature. From Goethe, Haeckl would learn to study the external forms and shapes of things, but to see these visible structures as indications of the inner life.
You must, when contemplating nature, attend to this in each and every feature. There's no outside and no within, for she is inside out and outside in. Thus will you grasp with no delay the holy secret, clear as day.
Goethe expressed this vision of unity through the figure of Faust, who, like the alchemist of old, aspired to encompass the whole universe and overcome all its contradictions. The alchemist tried to combine base elements into gold, to fuse sulfur and mercury into the philosopher's stone. But Goethe knew that the wedding of opposites within the alchemical vessel was only the outer sign of the alchemist's inner quest, to marry the opposites within the vessel of his own spirit. For Goethe, and for the Romantic poets after him, it was only the shape-shifting energy of the artist's imagination that had the power to embrace the opposites and heal the split between man and nature. They envisaged the act of creative imagination as welling up from the depths of an inner sea. To describe the power of this shaping spirit, they invoked the name of Proteus, a Greek god of the sea, capable of assuming an infinite variety of forms. This is Messina, at the northeast tip of Sicily, where Ulysses fought the Cyclops and steered his ship between Scylla and Charybdis. It was here that Ernst Haeckl's two worlds would meet. And for Haeckl, it was the tiny radiolaria that would, like the flasks and alembics of the alchemists, fuse these two worlds into one. The microscopic radiolarian is part of the floating oceanic plankton, a frothy amoeba-like drop of protoplasm with a network of branching pseudopods to engulf and absorb tiny prey. But the radiolarian also absorbs silica from seawater, then extrudes it to construct a glass-like skeleton. In each species, this translucent cage assumes a unique form. The radiolaria are over 500 million years old, among the earliest skeletonized life forms. They are like an alphabet of possibilities, as if the ancient sea were dreaming in its depths all the future permutations of organic and invented form, from backbones to bridges, and from the earth to the stars. Every age has its own vision of the world, and every image reflects the vision of its time and of its maker. Since the beginning of the age of the navigators, man's image of the world had been dominated by the sea, the one linked sea that covers 2/3 of the planet. By 1800, the contours of the ocean's surface were largely understood. But even in 1805, barely a generation before Ernst Haeckel's birth, a respected French naturalist was able to theorize that the bottom of the sea was covered in eternal ice, and that, as a consequence, life was impossible there. The depths were still a mystery, a region reserved for poetry and romantic myth.
And now the storm blast came, and he was tyrannous and strong. He struck with his o'ertaking wings and chased us south along.
The greatest romantic sea myth of the 19th century world was Samuel Taylor Coleridge's Rime of the Ancient Mariner. As the poem begins, an aged sailor recalls the strange voyage of his youth to a wedding guest who cannot choose but hear. He tells how his ship was blown far south by a great storm.
And now there came both mist and snow, and it grew wondrous cold, and ice mast high.
A mysterious albatross brings good fortune and a rescuing breeze. But the mariner offends the spirits of the deep and brings a curse upon the ship when he shoots the albatross. Soon, trapped in a Pacific calm, the mariner descends into nightmare. He lives out the consequence of a failure of vision, a split between man and nature. The Rime of the Ancient Mariner is an inward journey through a sea of poetic imagination, a sea of strange and dark-lit forms, inhabited by spirits and ruled by supernatural events. But Coleridge wove his vision on the loom of actuality. He had devoured the writings of the sea captains and explorers, of Frederick Martens in the Arctic and Captain Cook in the South Seas. The travelers' reports of water beasts, spectral lights, and phosphorescent seas lay beneath the fabric of his vision. Ernst Haeckl first turned his eyes on this world of the sea as a young medical student at Würzburg in the 1850s. It was a time of great ferment and excitement. Only a few years before, two German scientists had made the epochal discovery that cells were the fundamental building blocks of all life, animal as well as plant. Now, equipped with new and powerful microscopes, a young generation of naturalists at Würzburg and Berlin were unfolding the cell's mysteries.
Würzburg, December 21st, 1853. Dearest parents, I am generally lonely at home, except when I am sitting with my beloved microscope. There is a peculiar power of attraction for me in the strange fact that the cell is the origin and basis of all organic bodies. I consider this actually to be the greatest miracle of creation, about which I am more astounded and pleased than I can adequately express. A secret dark instinct tells me this is the field in which you can achieve something.
Haeckl and his colleagues abandoned the dried specimens of the university collections and the old ideas that went with them. They took microscopes and collecting nets to the shores of the Mediterranean to study the living contents of the sea. It was like opening a window on a whole new world. Men had long explored the coastal shallows, seeking shellfish, treasure, and pearls. By the 1820s, divers in cumbersome suits had descended 100 feet or more. Yet at the midpoint of the 19th century, the depths of the sea remained the farthest frontier, as the depths of space are to us. But with stimulus from an unexpected quarter, a new science of the sea was taking shape. At the start of the century, information had still traveled around the world by ship, and messages could take a year or more to reach their destinations. The invention of the telegraph in the 1840s had transformed communications almost overnight. Within a few years, cables had been laid across rivers, through jungles, across the English Channel, and then the Mediterranean. Then, as Haeckl pursued his studies at Würzburg, a man named Cyrus Field set out to lay a telegraphic cable across the floor of the Atlantic so that stock prices could flash from London to New York. Thousands of miles of cable were coiled in the huge hold of the Great Eastern, largest vessel of the century. Slowly, the huge ship proceeded from the British coast toward Newfoundland, paying out cable as it went. Several times the line snapped and plunged to the ocean floor. Several times it was recovered. Several times Field and his crew abandoned the crossing and began again. Eventually, in 1866, they would successfully connect the continents. The effort to link the world by cable produced a great surge forward in undersea technology. Suddenly, understanding the geography and geology of the ocean depths became a practical necessity. At the very least, engineers had to know if they were draping the cable over a mountain or dropping it into an abyss. Sections of cable were recovered from as deep as 3 miles. Some, to everyone's surprise, were encrusted with marine organisms. This was the first indisputable evidence of life on the ocean floor. The new oceanographers would develop a whole panoply of new tools, dredges and trawls that could gather samples from the ocean bottom, suspended by miles of rope, depth thermometers and sounding machines, water collectors to sample the chemical content of the sea, the tools they needed to sift and measure the depths. But when Haeckl was a student at Würzburg in the 1850s, The Atlantic Cable project was in its early stages, and undersea technology was still in its infancy. He and his colleagues gathered their specimens in handheld fine mesh nets from the bays and shallows of coastal waters.
Würzburg, August 4th, 1856. My dearest, beloved parents, it is only today that I find time to write you again, because the marvelous polyps, jellyfish, and corals have occupied me each day from 5 o'clock in the morning till 10 o'clock at night. I have been transported into quite a new world, just as though it were into another planet. My resolution to examine tropical seacoasts as a naturalist, especially as a zoologist, is now fixed. My entire and sole thought is concentrated on the sea and on its numerous and marvelous inhabitants.
In 1872, 6 years after the successful laying of the Atlantic Cable, the British government and the Royal Society would commission an expedition without precedent. Its mission would be to systematically explore the depths of all the world's oceans in a 3-year voyage that would circumnavigate the globe. HMS Challenger, a Navy corvette, would be stripped of its guns and ammunition stores and fitted with the tools of the new science. The Challenger would have a fully equipped chemical laboratory, a biological laboratory and dissecting room, and a scientific staff of 4 naturalists, a chemist, and an artist. This would be a voyage outward, a voyage through a sea of fact and measured quantity, a world of rigor and system. At every shore they visited, the Challenger naturalists would gather samples of flora and fauna, study weather and tides, chart coastlines and harbors. Nothing would escape their interest, and nothing would seem beyond their grasp. Above all, they would explore the deep sea. The Challenger scientists would chart the ocean's temperature and density and chemical composition. They would make hundreds of depth soundings and perform the first systematic analysis of the ocean floor. Ernst Haeckl would not be on board the Challenger, but the expedition would make a discovery in the ocean's greatest depths that would change his life. During Haeckel's university years, though, hopes of marine discovery seemed far away. His father insisted that he complete his medical studies. Haeckl overcame a distaste for disease and dissection to slowly earn his degree, and then spent 1 miserable year practicing as a physician. Finally, his father agreed to support a year of travel and marine research in Italy. Haeckl was 25 years old, full of dreams of great discoveries. He arrived in Naples in the spring of 1859, 13 years before the Challenger set sail. In England, Charles Darwin was about to publish The Origin of Species, and, half a world away, Cyrus Field's first attempt to lay a cable across the Atlantic had just ended in failure.
Naples, April 9th, 1859. The ocean samples have been poor so far, and I have been unable to come to steady, relaxed work. I find it increasingly difficult to sit alone here in my room, like a prisoner in the castle, and focus my attention on one tiny object under my microscope, while through my window, the azure ocean and the cloudless sunny sky, the colorful smoking mountain and the whole wonderful landscape are constantly tempting me outside. Naples, May 6th. After 6 weeks of steady work, the little that I have found stands in no relation to the strength and time I have put in. Worst of all, I'm beginning to lose faith that I have the real talent for this work. Only my excursions into nature seem worthwhile. My sketchbooks are filled with drawings.
It was a decisive period for Haeckl. For the first time, he met poets and artists and discovered in himself a love and talent for landscape painting. For the first time, he began to feel the conflict between the world of his scientific ambitions and the world of his romantic yearnings. He neglected his biological studies and seriously considered abandoning science for art. In the summer of 1859, as Ernst Haeckl explored the Bay of Naples, the British ship Fox was mapping the treacherous channels between Baffin Bay and the Arctic Ocean. To scientists and explorers, the seas of the world had become a treasure house of phenomena to be surveyed and analyzed. But for artists and poets, the deep was still the repository of the unconscious, or what Coleridge had called the reservoir of the soul, a place of luminous dreams and nightmares.
The very deep did rot. Oh, Christ, that ever this should be. Yea, slimy things did crawl with legs upon the slimy sea. The many men so beautiful, and they all dead did lie. And 1,000 slimy things lived on, and so did I.
Coleridge wrote The Rime of the Ancient Mariner as the 19th century was about to begin. Gustave Doré would complete his illustrations for the poem at his London press in 1874 as HMS Challenger circled the globe. The inward journey of Coleridge's Mariner and the outward voyage of the Challenger seem irreconcilable, like the two worlds of Haeckl's dilemma. But in fact, they overlap and share each other's nature. They are bound by a common geography, and they both found revelation in the depths.
Capri, in the Bay of Naples, August 7th, 1859. All my fine hopes for marine research have come to nothing. Now the unfavorable season with its glowing heat drives the tender little creatures to the depths and to the north. It seems I have carried microscopes, instruments, and nets in vain here. I shall try again this fall and winter in Messina, but the remaining weeks in Capri I shall devote to drawing and painting, for which indeed the richest and most beautiful material is everywhere in abundance.
Haeckl's constant companion in these days was the poet Hermann Almers, whom he had met on the boat from Naples. Almers later wrote, "We were 4 weeks in Pagano's excellent inn at Capri with a few artists, and Haeckl completely lost himself with delight. He was seized with a passion for painting landscapes day after day. He was especially interested in the most fantastically shaped rocks. He became intimate with the young artists. Being hitherto surrounded by men of scientific interests, he had avoided them."
Capri, August 16th. These last weeks with Almers, I have come to know a total artist's life in its charming, wild, and romantic sense. By contrast, the science life seems serious, cold, and rational. If my talent were equal to my desire, I should face the greatest temptation to give up nature science in favor of landscape painting. I feel like Faust, torn between two worlds.
To have creation's inmost power resounding through my mind, a shape of things in vivid flower issues from my hand. My touch, uncertain, stammering speech, but no resolve beget. I feel I know you in my reach. Nature, I'll have you yet.
Sometimes, nature gently intervenes on our behalf. In Coleridge's poem, as the mariner suffers his torments, the journeying moon rises in the sky. Suddenly, by an inexplicable movement of the spirit, the mariner's vision is transformed.
Beyond the shadow of the ship, I watched the water snakes. They moved in tracks of shining white, and as they moved, the elvish light fell off in hoary flakes. Oh, happy living things, no tongue their beauty might declare. A spring of love gushed from my heart, and I blessed them unaware. Sure, my kind saint took pity on me, and I blessed them unaware.
Now the sea brings him rain and sleep and redemption. The mariner's vessel begins to echo a vessel of another kind. For the alchemist, a bird in flight, like the mariner's albatross, symbolized the beginning of the transformative process. Like the mariner in his ship, the contents of the alchemical vessel must suffer ice and fire, rot and decay on the journey to redemption. And the image of the completion of the chemical wedding, the unification of the opposites, was a dragon or serpent in flames.
Blue, glossy green, and velvet black, they coiled and swam, and every track was a flash of golden fire.
It is no coincidence that Coleridge's Mariner tells his tale to a wedding guest, with the sound of the marriage feast drifting in and out of his telling. The bird, the serpents, the sacred wedding. Like all alchemists, he speaks in parable and code.
Messina, October 29th. The difficulties that surrounded me in Naples and in Capri are starting in this place to disappear. The Fisher boys made 6 deliveries today, and I am surrounded by such an abundance of material that it is hard to know where to begin. I find myself looking forward to the winter, of which I was so afraid, with wonder, yes, with certain hope.
Messina was prized by the new zoologists. A unique combination of wind and tide traps millions of microorganisms in the cul-de-sac of the harbor. When Haeckl first dipped his net into this animal stew, he met the living Radiolarian.
Messina, December 15th. I have come at last upon a subject for my main work. I am now engaged with full speed and eagerness in the study of the Radiolarian rhizopods. These remarkable creatures are at the lowest border of animal life, and if only because of that, are worthwhile objects of study. They were first discovered in skeletal form by Ehrenberg and then observed alive by my teacher, Johannes Müller. About 50 species are known, but I am already finding entirely new types among my samples.
In 1859, the existence of independent single-celled organisms was still considered doubtful. When Ehrenberg discovered Radiolarian skeletons, he had thought they might be some sort of byproduct or construct of larger and more complex creatures. But it became clear to Haeckl as he worked that each of these creatures, despite its complexity, was both a separate organism and a single cell. Later, he would give the creatures of this kingdom their name, protists or protozoa. The work was extraordinarily painstaking. He used a pipette to place a single drop of seawater on his microscope stage, sometimes searching 1,000 drops to find a single new specimen. For his preliminary drawings, he used the camera lucida. These devices used prisms, tinted glass, or mirrors to allow an artist, with practice, to look through the microscope image to his pencil and paper below. Haeckl had to work fast to draw the living creatures. They could only be kept alive a very brief time, and the complex structures of the Radiolaria could be made clear only with the strongest magnification and precise angling of the lamplight.
Messina, February 29th, 1860. Every morning I am newly amazed at the inexhaustible richness of these tiny and delicate structures. It is hard to believe that each of these creatures is a single cell. Some are like grids or broken nets or stars, others like tiny bowls or helmets or bells. still others like tender houses, windmills, and fantastic towers. That I thrust myself with sheer passion on these scientific treasures, which are simultaneously so pleasing to the aesthetic eye, you can well imagine.
And suddenly, the conflict within Haeckl between mind and heart, precision and passion, began to melt away. Like Coleridge's mariner, he looked into the sea and suffered a transformation of the spirit.
Everything now came before me in new and beautiful and remarkable forms. I began to see and hear not only the outer forms, but also the inner content, the nature and the history of things.
Oh, happy living things, no tongue their beauty might declare. A spring of love gushed from my heart, and I blessed them unaware.
After Messina, Haeckl's path was clear. In 1862, he published his monograph on the radial area, describing 144 new species. He was galvanized by Darwin's new theory, which Haeckl took as a challenge to reconstruct the biological history of life on Earth. But how could this be done? The fossil record provided clues, but the known fossil record in the 1860s was woefully incomplete. Haeckl drew on the strengths of German comparative anatomy and embryology to articulate what he called the biogenetic law, that ontogeny recapitulates phylogeny, that the developing individual embryo relives all the stages of the evolution of the species. With the aid of the biogenetic law, Haeckl believed that huge gaps in the fossil record could be filled. Haeckl quickly became the leading champion of evolutionary theory in Europe. In 1866, he published his General Morphology, a search for the origin and pattern of organic form, that named and defined the new science of ecology and introduced the image of the evolutionary tree of life. Haeckl dared to publicly proclaim both the origin of life from inorganic matter and, years before Darwin, the ancestral connection between man and ape. By the 1870s, he was 40 years old and a star professor at the University of Jena, where students from throughout Europe flocked to his classes and lectures. Then came the voyage of the Challenger. The Challenger scientists left England in 1872. They crisscrossed the Atlantic and then, like Coleridge's mariner, headed for Antarctic waters.
February 18th, 1874, latitude 64 degrees south. The coldest weather yet experienced. Temperature of air down to 23½ degrees. All the forenoon we sailed through vast fields of ice. Some of these great perpendicular masses overtopped our mastheads by many feet.
They too met an albatross, but it brought no curse. It was caught with a fishhook and added to their specimen collection. When the Challenger reached the Antarctic Circle, she changed her course and headed north, like the ship of the poem, into the heat of the Pacific.
April 1874, latitude 40 degrees south. The vastness of the ocean is constantly brought home to us by the tedious length of time required for the operations of sounding and dredging in it. From daybreak to night, a donkey engine is heard grinding away with a painful noise as the sounding line and thermometers are being reeled in. At first, when the dredge came up, every man and boy in the ship who could possibly slip away crowded round it to see what had been hauled up. Such a sight when it is really inboard. Here we have no lack of wonderful things.
In the mud from the ocean floor, they found a multitude of life forms, many of them previously unknown. This was, for the 19th century, like bringing living creatures back from the moon. The seafloor mud, when washed and sifted, consisted almost entirely of the shells of countless one-celled organisms, mostly foraminifera and tiny mollusks. But the thin-shelled mollusks disappeared below 1,500 fathoms, apparently dissolved by the acids in seawater as they drift slowly downward. In the deepest samples from 3,000 fathoms, or about 3.5 miles, skeletal material virtually disappeared. Tangatabu, July 19, 1874. Api, New Hebrides, August 17. Basilan in the Philippines, October 24th. The scientists examined native architecture and artifacts, described rituals and customs, speculated on the origins of dance and drama and art. They questioned everything, except their own superiority. That European man was the pinnacle of evolution seemed to most Europeans a fact too obvious for debate. While the Challenger was at sea, Haeckl in Jena was expanding the ambition of his program. He surrounded himself with a circle of philologists, ethnographers, philosophers, and theologians. Evolutionary theory would become the basis for a new view of man and a remaking of human society on the model of nature. But Haeckl was not immune to the prejudices of his time. As he elaborated his theories and constructed his phylogenetic trees, he saw in the rich variety of human cultures only the culmination of his patterns, a steady upward progression to the pinnacle of his own time, place, and culture. It was his, and his century's, deepest flaw.
March 23rd, 1875, observing station 225 off the Marianas Islands. Today, we have had a most unexpected result.
The sounding machine registered 4,475 fathoms, a depth of more than 5 miles.
The result has been rechecked and confirmed. It is the deepest man has ever reached into the earth. And there is another surprise. The sea bottom at this great depth is covered once more with the remains of one-celled creatures, but not forams or mollusks. These are the radiolaria, so called because of their intricate radial symmetry. Their skeletons are of glass-like silica and almost impervious to seawater. They have been studied by Haeckl in shallow waters, but this is a treasure trove of new species.
The Challenger headed south, moved through the Straits of Magellan, and made its way toward home. When the expedition reached England in the spring of 1876, it brought back a colossal and unprecedented collection of specimens. They were distributed among the leading scientists of the day for study, men like Thomas Henry Huxley and Alexander Agassiz. Together, these scientists would produce an encyclopedic report of more than 50 thick volumes. The report on the radiolaria and the rich sedimentary deposits from the depths of the Marianas Trench were entrusted to Professor Ernst Haeckl of the University of Jena. Haeckl devoted himself for 10 full years to the vast riches of the Challenger radiolaria, seeking the characteristics that would define species and families within a welter of individual specimens. It was a monumental task. Slowly he arranged his specimens in chains of related forms and began to trace their ancestry and relationships. When he released his report in 1887, he had identified and luminously documented more than 3,000 new species. The radiolarian, like the sea god Proteus, seemed capable of assuming an inexhaustible variety of forms.
Swiftly, swiftly flew the ship, yet she sailed softly too. Sweetly, sweetly blew the breeze. On me alone it blew.
Angelic creatures appear and guide Coleridge's mariner safely homeward. But he will be doomed to wander, repeating forever the tale of his sea change. After his decade of labor on the Challenger report, Haeckl began to travel incessantly to the Near East, Java, Ceylon. He collected specimens, wrote books of his travels, and remained a passionate painter of landscapes. As always, he was drawn to images of richness and profusion, to bizarre and involuted forms.
From my earliest youth, I have yielded to the inclination of my heart and studied incessantly one great book, nature. This greatest of all books has taught me to know the true God, the God of Spinoza and of Goethe.
Now Haeckl's lecture halls were like the temples of some new religion.
The unitary idea of God, which alone is compatible with our present knowledge of nature, can never recognize in God a personal being, or in other words, an individual of limited extension in space, or even of human form. God is everywhere. As Giordano Bruno has it, there is one spirit in all things, and no body is so small that it does not contain a part of the divine substance whereby it is animated.
Where Friedrich Nietzsche had seen in Darwin the loss of meaning and the death of God, Haeckl saw what today would be called a self-organizing universe. He believed that evolution led inexorably upward, not only to man, but beyond, in an endless refinement of structure. Ultimately, he came to see all of nature as a single unfolding work of art, and always he used the radiolaria as a touchstone, referring to them again and again as he described the formative forces that gave shape to life. His outspoken ideas thrust Haeckl into a storm of controversy and made him the target of attacks from the church and the academic establishment. For others, he was a symbol of enlightenment and free thought. Cast in the role of prophet, he became one. In books like The Wonders of Life and The Riddle of the Universe, he held that the world cannot be divided into the organic and the inorganic, or into matter and spirit. He spoke of the lives of crystals and the souls of cells.
I pass like night from land to land. I have strange powers of speech. That moment that his face I see, I know the man that must hear me. To him my tale I teach.
Even as a very old man, Haeckl held to his belief in the unity of matter and spirit, denied the immortality of the soul, and declared the open spaces of nature to be the only church man needs. At the end of his career, he wrote, "I am wholly a child of the 19th century, and with its end, I would draw the line under my life's work." Haeckl's legacy to the 20th century was a strange one. Lenin would extol his work as a great weapon in the class struggle. Sigmund Freud would base his theories of development and the unconscious on Ernst Haeckl's biogenetic law. Haeckl's nature mysticism would have a profound effect on the literature of D.H. Lawrence, and his images of undersea creatures would shape the sinuous forms of Art Nouveau. As the years went by, many of his theories would be rejected, while his vision of endless progress would be shattered on the battlefields of World War I. The Nazis would ban his books, while using his ideas to support the madness of racial purification. Today, Ernst Haeckel, whom Thomas Edison once called the greatest of living men, has faded from popular memory. But biology, as a systematic and historical science, still bears his imprint, and his images remain a testament to what he and Goethe would have called the infinite unfolding of God in nature.
Farewell, farewell. But this I tell to thee, thou wedding guest. He prayeth well who loveth well, both man and bird and beast. He prayeth best who loveth best all things, both great and small. For the dear God who loveth us, he made and loveth all.
Many years ago, as now, my mind strove with eager delight to study and discover the creative life of nature. It is eternal unity in manifold manifestation. The great is little, the little is great, and everything after its kind, ever changing and yet preserving itself, near and far and far and near, and so shaping and reshaping itself. I am here to wonder at it.